So now I added a Schmitt trigger to my comparator circuit, and the signal we're shooting for is about half of the supply voltage right there. So we're well below that and the output is low, but it's a Schmitt trigger. We go up, and again, it's still a comparator and non-inverting, so high enough input, we got a high output. But there is a middle ground region, so I go halfway, output stays high, go down, it's low, go halfway, it stays low right there. We got a middle ground region called hysteresis. And the reason why is because this op-amp comparator, the output has a 10K resistor coming back to the plus input, which is the signal that we're comparing with the inverting input. And therefore it's helping. The output is high right now. It's raising that signal voltage to the inverting input. So making it so I gotta go down a little bit farther. But now that we got a low output, it's pulling that voltage down. So I'm gonna have to go up further again. So now, here's the schematic diagram for my op-amp comparator with hysteresis right there. So, first off, we got the comparator. I got half of the supply voltage. If you're using 5 volts, it's 2.5 volts to the inverting input. And make sure you pay close attention to where the plus and minus are. Sometimes they're swapped. And then the signal we're comparing it with, of course, is to the plus input, the non-inverting input. But you notice, that is connected to the output. So, when the output is high, it's got a higher voltage. That raises the voltage at the non-inverting input from what the trim pot is right there. So you got to go down an extra amount before it's going to set the output low, before you got a low enough voltage to set the output low. But once you do, then you got a decent ground connection to the output. That's going to pull the voltage down even farther right there. So you got to go up an extra distance in order to get a high input. So now we got the pocket oscilloscope to look at our Schmitt trigger comparator with hysteresis. So you're going to see when we get to 2.5 volts, halfway up the third square right there, the output is going to change from low to high. But then the signal voltage is going to jump up a little bit. So output is high, red LED. So I got to go back down to 2.5 volts before the output will switch back to low. So it's jumping back and forth. Maybe a little hard to see. So let's do 0.5 volts per division. So we got twice as many squares it's going to move per volt right there. So yeah, hopefully you can see those jumps. But yeah, when it comes to the Schmitt trigger, you need a positive feedback resistor if you're using an op-amp or a comparator. So we have the output coming to the plus input. That's the signal we're measuring right there. So when the output is high, that helps pull the voltage up. You got to turn the signal down further to get a low input. But once you do, then the output will go low. And that's going to pull the voltage down even more. So you got to go up further in order to set the output high.